Hello guys, I am Rakesh Marwanda. This is my third class and my chapter is relation and my topic is type of relations. So, in this class I start from the first lesson is void relation. Void relation. So, if A is a set, then phi subset equal to A cross A is a relation. This relation is called void relation or empty relation. In other words, you can say if R is a relation on A is said to be void relation if no elements of A are not related to any elements of A. Is called empty relation or void relation. Such as example, if A is a set containing 1, 2, 3, 4, 5, R is a relation so that A minus B equal to 12. Here we can observe that A minus B not equal to 12 for all AB belongs to A, so that A minus B, AB not belongs to R for all AB belongs to A. So R does not contain any elements of A cross A. So R is empty set. So R is a void relation. So the definition is gives us if R is a relation on A is said to void relation if no elements of A are not related to any elements of A. So this relation is called smallest relation of set. So this is our void relation. Next, universal relation. Saying if A is a set, then A cross A subset equal to A cross A. A cross A subset equal to A cross A. It is a relation. And this relation is called universal relation. In other words, we can say if R is a relation on A is said to be universal relation if each element of A are related to every element of A. This is the most important line. If each element of A are related to every element of A, and this relation is called universal relation. For example, if A equal to 1, 2, 3, 4, 5, R is relation equal to AB such that A minus B mod greater than equal to 0 is a universal relation. Because here you observe that A minus B mod is always positive quantity, so is greater than equal to 0. So for all AB belongs to A, here AB belongs to R. For all AB belongs to A, so that R containing all elements of A cross A, so that R equal to A cross A mean each element of A are related to every element of A. Here each element of A related every element of A, so that R is called universal relation. So R is universal relation. Universal relation. And this relation is called largest relation on a set. Void relation is the smallest relation and universal relation is the largest relation on a set. Now discuss about identity relation. Third point, identity relation. Saying if A is a set, R is a relation, R is a relation is said to be identity relation if each element of A are related to itself only. So itself only is the important point. If A is said, R is a relation is said to be identity relation if each element of A are related to itself only. So the example, A equal to 1, 2, the relation R equal to 1, 1, 2, 2 is a identity relation. So identity relation is denoted by IA equal to A, so that A belongs to A is called identity relation. Here R equal to 1, 1, 2 is identity relation. Example 2. B is a set containing elements A, B, C. For R is relation, suppose R1 equal to A, B, B, C, C. So this relation is called identity relation because here each element of A are related to itself. A related to A, B related to B, C related to C only. No other order pairs are here. Only 3 order pairs are here. Same here 2 order pairs are here because the number of elements of A is 2. So total number of order pair is 2. Here number of elements is 3. So total number of order pair is 3. 1, 2, 3. So here only A related to A, B related to B, C related to C. No order pairs are here, other order pairs are. So this relation is called identity relation. So now I know number of identity relation. Number of identity relation on a set is 1. In any set there is only one identity relation. So this is our identity relation. Now I discuss about our next relation, which is reflexive relation. 4 point reflexive relation. Reflexive relation means if A is a set, R is a relation, is said to be reflexive relation. R is reflexive if A belongs to R as A belongs to A. For all A belongs to A. A belongs to R or all A belongs to A is called reflexive relation. So, reflexive relation, in other words, gives us if R is a relation on a set A is said to be reflexive, reflexive if each element of A are related to itself. But not itself only. Only itself. Itself only not. So here R is a relation on the set A is said to be reflexive if each element of A are related to itself, and this relation is called reflexive relation. So reflexive relation is a relation which is each element of A related to itself. A relation R is a relation is not reflexive if there exists a element A such that A not belongs to R. If R is a relation is not reflexive, if there exists an element A such that A not belongs to R is called not reflexive. So reflexive means each element of A related to itself most. So the example 1, identity relation is a reflexive relation. Identity relation is a reflexive relation. Example 2, universal relation is also reflexive relation. Next point. Let A equal to 1, 2, 3. R is the relation gives us 1, 1, 2, 2, 3, 3 is a reflexive relation because the definition gives us each element of A are related to itself, so that here A equal to 1, 2, 3. So 1 related to 1, 2 related to 2, 3 related to 3. So this relation is called reflexive relation. So the next example is example 4. If R is a relation defined as number of lines parallel, number of parallel lines in a plane is a reflexive, because the board is a plane. Here I draw some lines as we take 3 lines only, L1, L2, L3. There are 3 lines which are all are parallel to itself. So here L1 parallel to L2 and L2 parallel L3. L1 parallel to L2 parallel to L3. So here we know each line is parallel to itself. Here each line parallel to itself, so that the relation is reflexive. When L1 parallel to, so L1 parallel to L1, L2 parallel to L2, L3 parallel to L3. So this relation is called reflexive relation. Next, I give another example, such as example 5. If R is a relation on a set A, R equal to AB, such that A greater than equal to B. This relation also reflexive relation, because here the relation gives us A greater than equal to B, means either A equal to B or A greater than B, means sometimes each element equal to itself and sometimes each element is less than to another element. So here A belongs to A, or B belongs to R, C belongs to R, for all AB belongs to A. So this relation is called reflexive relation. Next, number of reflexive relation on a set A. If cardinality of A equal to n, then total number of relations which are reflexive is 2 to the power n square minus n. This is the formula. If R is a relation, number of relation on a set A, if R is a relation and the cardinality of A equal to n, then total number of reflexive relation is 2 to the power n square minus n. If n equal to 1, then we can put here 1. If n equal to 2, then we can put here 2. So this relation is called reflexive relation. So now the next relation is irreflexive relation. Irreflexive relation. You can write also here irreflexive relation. Irreflexive relation means if as is said R is a relation is said to irreflexive if A not belongs to R or all A belongs to A is called irreflexive relation. Means same element are not related to same element. So here A not belongs to R. So this relation is called irreflexive relation or anti-reflexive relation. So here if R is a relation on a set A, then R is the relation A not belongs to R, so that A belongs to A. A not belongs to R, so that A belongs to A. This relation is called irreflexive relation or anti-reflexive relation. Such as example, if A equal to 1, 2, 3 and R is the relation is 1, 1, 2, 2, then the relation is not a reflexive relation, not a irreflexive relation. Suppose here we can take 1, 2, 2, 3 or anything is also irreflexive relation but not reflexive relation. Here A equal to 1, 2, 3. Let's suppose first relation gives us 1, 1, 2, 2, 3, 3 is a reflexive relation. Is reflexive relation. Is reflexive relation because 1, 1, 2, 2, 3, 3 each element of A are related to itself. So this is a reflexive relation. Second, R2 1, 1, 2, 2, 3, 3 again also 1, 3. This is also reflexive relation because here 1, 1, 2, 2, 3, 3 are mandatory parts are here already given there. So any other pairs are present or not justified, but 1, 1, 2, 2, 3, 3 is most important to present any relation to know reflexive relation. So this is the relation is reflexive relation. R3 is the relation 1, 1, 3, 3, 2, 3. This is not reflexive relation. This is not reflexive. Not reflexive. Because here 1, 1 present, 3, 3 present, but 2, 2 not belongs to R. Because 2, 2 not belongs to R3. So this relation is not reflexive. So here we discuss about reflexive relation and irreflexive relation. Reflexive means each element of A are related to itself, but irreflexive said us each element of A are not related to itself. So now I discuss about total number of irreflexive relation. So number of irreflexive relation is on a set A whose cardinality equal to n is 2 to the power n square minus n. Reflexive relation is equal to irreflexive relation. The total number of irreflexive relation on a set A is 2 to the power n square minus n. So now I discuss about the next relation, which is symmetric relation. Symmetric relation means if R is a relation on set A is said to be symmetric, if and only if AB belongs to R, that implies BA belongs to R for all AB belongs to A. As A related to B, that implies B related to A most. So this relation is called symmetric relation. In other words, we can say a relation is said to be symmetric relation if there exist two elements AB such that AB belongs to R, then that implies B also belongs to R is called symmetric relation. If R is a relation is not symmetric if there exist at least two element such that AB belongs to A and AB belongs to R, but BA not belongs to R. A relation R is a relation is not symmetric if there exist at least two elements so that AB belongs to A and AB belongs to R, but BA not belongs to R is not a symmetric relation. So here the symmetric relation is gives us AB belongs to R, that implies BA also belongs to R. For all AB belongs to A related to B, that implies B related to A is a symmetric relation. In first example 1, identity relation is symmetric relation. Second, universal relation is symmetric relation. Third point, if R is a relation which gives us R is a relation defined as number of perpendicular lines in a plane. As number of perpendicular lines in a plane, we take two lines such as L1 and L2 here L1 perpendicular to L2. So in this definition, here we know L1 perpendicular to L2 and L2 also perpendicular to L1. So L1 L2 belongs to R and L2 L1 belongs to R. So this relation is called symmetric relation. Next example, if A is a set containing elements 1, 2, 3, R is the relation gives us 1, 1, 2, 2, 3, 3. Here, this relation is identity relation, this relation is reflexive relation, and this relation also symmetric relation, because the definition gives us if AB belongs to R, that implies BA belongs to R for all AB belongs to A. Here 1 1 belongs to R. Again we can change the position or place of 1 1 again belongs to R. Here 2 2 belongs to R. If we change the position 2 2 or inverse, then also belongs to R. 3 3 also belongs to R. So this relation is called symmetric relation. Suppose R2 here 1 1 2 2 3 1 1 3. Here 1 1 present, again position change present. Here 3 1 present, opposite position 1 3 is present. So this is also a symmetric relation. Let R3 is a relation gives us 1 2 2 1 3 1. Here we observe 1 2 present here, so 2 1 also present here. Here 3 1 present, but 1 3 is not present. Here 1 3 not belongs to R3, so this is not a symmetric relation. So here R1 is symmetric, R2 is symmetric, but R3 is not symmetric relation. So this is our symmetric relation. So now we know number of symmetric relation on a set. If cardinality of A equal to n, then number of symmetric relation on A is 2 to the power n into n plus 1 by 2, total by 2. So number of symmetric relation on a set whose cardinality is n is 2 to the power n into n plus 1 by 2, and this relation is called symmetric relation. Now you know anti-symmetric relation. Next example, anti-symmetric relation. If R is the relation on a set is said to be anti-symmetric if and only if AB belongs to R and BA belongs to R, that implies A equal to B for all AB belongs to A. This relation is called anti-symmetric relation. Anti-symmetric means AB belongs to A, R, B also belongs to R, that implies A equal to B for all AB belongs to A is called anti-symmetric relation. So the example, first thing, identity relation is anti-symmetric relation. Anti-symmetric relation. Second example, here we can say a relation which is identity with reflexive, also anti-symmetric relation. Means identity relation is also reflexive relation, identity relation, reflexive relation, both is a anti-symmetric relation. So here a anti-symmetric relation is a relation which gives us AB belongs to R and BA belongs to R. That implies A equal to B for all AB belongs to A is a anti-symmetric relation, and the relation are defined as x less than equal to y or x greater than equal to y is a anti-symmetric relation. Anti-symmetric relation on natural number n. The relation R defined as x less than y or x greater than y is a anti-symmetric relation on n, because sometimes here x equal to y or x less than to y, or here x greater than equal to y is anti-symmetric relation. So anti-symmetric relation gives us AB belongs to R and B belongs to R, and A equal to B is anti-symmetric relation. So now you know number of anti-symmetric relation on a set A which coordinate equal to n is 2 to the power n into 3 to the power n square minus n by 2. So this is the number of anti-symmetric relation. Now I discuss about the next relation, which is asymmetric relation. Asymmetric means if R is a relation of set A, is said to be asymmetric relation. Is said to be asymmetric relation if here AB belongs to R but BA not belongs to R, is called asymmetric relation. Asymmetric relation means if R is a relation on a set A and AB belongs to R but BA not belongs to R, is called asymmetric relation. So saying number of asymmetric relation on set A cardinality A equal to n is 3 to the power n square minus n by 2. This is the number of asymmetric relation on a given set. So asymmetric means a relation R is on a set A is said to be asymmetric if AB belongs to R but B not belongs to R. So next, now I'll discuss about the last relation, which is transitive relation. Transitive relation. Transitive relation means if A is a set, the relation R, a relation R on A is said to be transitive if AB belongs to R and BC belongs to R. That implies SC belongs to R for all A, B, C belongs to A is called transitive relation, as A related to B and B related to C, that implies A related to C, and this relation is called transitive relation. So here AB belongs to R, BC belongs to R, SC belongs to R. So the example, first identity relation identity relation is transitive relation. Transitive relation. Second example, if A equal to 1, 2, 3, the relation R equal to 1, 1, 2, 2, 3, 3 is a transitive relation. The relation 1, 1, 2, 2, 3, 3 is a transitive relation because here 1, 1 belongs to R, again it change position, 1, 1 belongs to R, again 1, 1 belongs to R. So this relation is transitive relation. Suppose R2 is another relation such 1, 2, 2, 3, 1, 3. Here 1, 2 belongs to R2, 2, 3 belongs to R2. So 1, 3 again belongs to R3, R2. So this relation is called transitive relation. Transitive relation means here 1, 2, here 2, 3 and the relation again first to second. Next example, in general example 3, if A is a friend of B, if A is a friend of B and B is a friend of C, if A is a friend of B and B is a friend of C, then also A friend of C. This is a general example of transitive. Next example, example 4. R is a relation defined as similar triangles in a plane such. So here 3 triangles all are similar. Here 3 triangles are similar. So this relation is a transitive relation because first triangle, second triangle, third triangle. Here first triangle is similar to second triangle and second triangle similar to third triangle. So first triangle also similar to third triangle. Similar triangle means each elements are corresponding elements are equal. Here also same, here also same. So R is a relation defined with similar triangles in a plane is transitive. Transitive relation. Same. Another example 5. R is a relation defined as parallel lines in a plane is transitive because here we take 3 parallel lines as L1, L2 and L3. Here you observe that L1 parallel to L2, so L1 related to L2. L2 parallel to L3, so L2 related to L3. That implies L1 L2 belongs to R. Here L2 L3 belongs to R. Now you observe that here L1 parallel to L2 and L2 parallel to L3, so L1 also parallel to L3. Same. That implies you observe L1 parallel to L3. So L1 related to L3, that implies L1 L3 belongs to R. So this relation is called transitive relation. So transitive relation means if AB belongs to R and BC belongs to R, that implies SC belongs to R. If you take more examples, such as another example I give you. Example 6. If R is a relation defined on set N is X divides Y. If X divides Y is transitive. Because we can prove here, let the set A equal to N means set of natural number. So here we can observe that X divides Y means Y equal to something of X. So here X related to Y, that implies X divides Y. So that implies Y equal to Px. P belongs to N. Again, Y related to Z, that implies Y divides Z, that implies Z equal to Qy, that implies Q belongs to N. So here we can write Y equal to Px and Z equal to Qy, so that Z equal to Qy, we can write Z equal to, in position of Y, you can write Px Q, that implies Z equal to X PQ, where PQ belongs to any natural number. So here we conclude that Z X divides Z, that implies X related to Z. Because first of X related to Y, X divides Y. Here again Y related to Z means Y divides Z. Z equal to Qy. Here again Y equal to Px. Then X related to Z. We concluded. So if X related to Y and Y related to Z, we conclude that X related to Z is a transitive relation. So this is my topic, and my chapter is relation. My topic is type of relations. So here we discuss about so many types of relations. First of thing, I give you void relation, universal relation, identity relation, reflexive relation, irreflexive relation, symmetric relation, anti-symmetric relation, asymmetric relation, and then after I give you transitive relation. So in my next video, I will give you what is equivalence relation and number of equivalence relation on a given cell. So if you like my channel and if you like my topic of relation chapter, then please subscribe my channel, and thank you so much for all of you guys who are likes to me and see my channel totally first to last. So thank you so much.